Hello, welcome back. So today in this video I would like to show you the projections of a nut, and I will show you in third angle projection system. So first let's see the nut. So this is a bolt and this is the nut. So we will do the projection of this nut. So you can see in the top view and the front view and the side view. So, and first thing, for any kind of nut or bolt, we should find out what is the major diameter. So major diameter is fixed for the nut or for the bolt. So here today we will start with, or we will use the major diameter as 20 millimeter. So with 20 millimeter as the major diameter, we will draw the projections of the nut. So first, before we start drawing, let's do this small calculation. So you should first write d equal to 20 millimeter, and then you should do this calculation. So this is across the flat. So we are going to use a hexagonal nut. So hexagonal, as you can see, has got this kind of shape: 1 2 3 4 5 6. So 6 faces. So AF is basically this distance across the face, or this distance. They will be all same. So first we calculate AFs. So this is a formula, a standard formula. There could be some other formula, but we will use this one: 1.5 times d, which is fixed, plus 3 mm. So this gives us 33 millimeter. We should also calculate r. So I will show you how we will use r. So r is equal to half of AF. So half of AF will be 16.5 millimeter. And also we should calculate this 0.9 d. So 0.9 times d will be 18 millimeter. So we will use these three data in our drawing. So first we should calculate these three. So now let's draw the reference line somewhere in between. So this is the reference line, x and y. And with this reference line, we draw the center line. So now, since we are going to make third angle projection system, so the top view will be here above the reference line, and the front view will be below the reference line. So as you can see, the top view is something like this. So we will make the top view first. So now we have already calculated across the flat 33 millimeter. So this is taking 33 as the diameter. So if we take the radius, it will be half of it. So 16.5. So let's draw a circle of 16.5 millimeter radius. So first we draw the circle and locate the center of the circle and then draw the horizontal diameter. Now, using the same radius on your compass, you cut at these points. So this basically makes a 60 degree. So this angle is 60 degree, this angle is 60 degree. So now we will make draw tangents. So for drawing tangent, there is a easy way by using these protractors. Okay, before that we should connect these lines actually. So we will just darken these lines because these are outlines. So this, we have made hexagon outline of this nut. So another thing we should do is take the major diameter. So major diameter is 20, so take 10 mm on your compass as the radius and draw a circle here. So let's first delete this one or erase this one because we don't need this. And this circle we will not draw it complete. So this represents the major diameter of a nut, because the nut has internal diameter, so the major diameter is not completed and the minor diameter will be completed. So we will just use a radius here because we have not calculated the minor diameter. So remember this, that the major diameter is not completed, it's left broken here, and the minor diameter is complete. So this is a complete top view of the nut. So now we will draw the front view. So we will draw the front view from here. So let's draw a line first and then project all the points. So initially you should use very thin line, and once the view is done, then you can darken the outlines. Now the thickness of this nut is 0.9 times the major diameter. So this is what we had calculated, 0.9 times 20. So this is 18 millimeters. So we will use 18 millimeters. So So we can darken this outline as well. Okay, so now since this has got chamfer, so therefore in the front view, which is something like this, we will see a curved surface here, an arc. So for arc for this one, which is in the complete view here, so true length, true dimension, and these are projected. So now we will try to draw these arcs. So now you remember we had calculated R as 16.5. So we will take 16.5. So this is R. So first thing you should do is from this center draw a partial circle here. So this one circle and another circle from here at the intersection of this circle and the center line, taking this as the center, and another circle. So basically we have to draw some arcs here. So these are the crossing points. After this, we should take this as the radius. So this length is basically across the flat length, because we have taken half of the cross here and half here. So this is basically total across the flat. So we take this as like this and then draw an arc. So we have to draw the arc from here to here. So this arc will be an outline, so we can make it darker. And then after that, we can use this as the center, and here at this intersection point, so intersection point of this edge and this first arc, and draw another arc here. Similarly, using the same radius, okay, so now we can just erase this one, these two circles. And draw the outlines. So this is the front view of the nut, which is like this. Now we will draw the side view. So for side view, we can get the projections both from the top view and from the front view. So you may know this method, where we have to draw a line which is at 45 degrees to the reference line, and draw the projections . Always use light pressure so that you can make very thin lines. So in case you have to erase them, then it's easier, much easier. Okay, so we have got these dimensions done. So now the base is here. So this is the side view. And to get the side view, what we will do is we will use this as the radius. and using the same radius we draw another circle. So basically another arc. Now roughly in the center here you can draw this arc here. Similarly for this. So remember, the radius is from this point to this. So now we have made the arc, and now we can erase this one. Now we can complete the outlines here. So remember, always the outline is dark line, that means the thick line. So now we can just do small dimensioning here. So this will be across the flat. So across the flat we have calculated as 33 millimeter. So this is 33 millimeter. But the basic dimension we started with was the major diameter, so we can actually dimension the major diameter. And this is D, which is 20 mm. So since it is diameter, we can show it like this, in inclined phi. So this is the third angle projection of a nut. So we have done the top view, the front view, and the side view. Thank you very much for watching this video, and if you like this video, please do click the like button. Thank you so much.